we're going to find the equation for the rational function drawn here. And there's actually a whole lot of hints in this picture. We just need to go at it one piece at a time. And the very first thing I want to talk about is what is going on this side of the graph. In other words, where is the function? We can't quite see it, but it has to be either up here somewhere or down there somewhere. Okay, it's one of those two things. And let me show you why the lower one does not work. Look right here where it says there are no x-intercepts outside the viewing window. That means this right here does not work because that would create a false x-intercept. So that means the function must exist somewhere in that top portion. So it just pretends it's up there. It's probably like way out here or something where you can't see it on the picture. Doesn't matter. So now we make a fraction, and we're going to start putting in all the pieces from our graph as we name them. Okay, I'm going to start off with blue. I have an x-intercept right here. Okay, that x-intercept is not only an x-intercept, but it's an even x-intercept. See that bounce? It bounced off the x-axis, which means it's an even x-intercept. So when I say x plus 5 over here, it's not just x plus 5, it's x plus 5 squared. There's no other x-intercepts, so I'm all done with that. Now let's talk about our vertical asymptotes. So here's one, and here's another. And both of these vertical asymptotes, if you look at them, are odd. Okay, these are odd vertical asymptotes. The reason I say that, I'm not trying to poke fun at them or anything, it's just that if you look at this side, let me get my highlighter back on here. If you look at this side, see how the function's right there? And then over here, the function is down on the lower left side. That asymmetry in the vertical asymptote makes it odd. And likewise over here, there's part of the function on the top left, and here's another part of the function on the bottom right of that asymptote. So those are two odd asymptotes. That means they don't have any exponents at all. So we're going to have one of them on the left at x plus 3, and that's going to be a single exponent. You don't need to write a 1 as an exponent. I'm just doing that to be clear. And then I've got an x minus 5 vertical asymptote, and that also has a single multiplicity or exponent of 1. Okay, this is pretty good. There's one thing I've left out. So we want to make sure we talk about this little booger. That is a hole in the function, and it creates a factor on the top and the bottom. And all we care about is where the x value is located. So that's x plus 1 on top and bottom. This thing's basically done. Now we just have to figure out what is the scaling factor in front. What is that a term? It's going to be a number. It could be 3, it could be -2, it could be a quarter. The way you figure it out is you plug in a non-zero y value. And, ooh, we've got one right there. That's going to be 0, -5. So I'm going to plug that in. Yeah, I'm going to plug that in. So I get -5 is my y value, equals a times 0 plus 5 squared, 0 plus 1 on top. On bottom, we get 0 plus 3, 0 minus 5, and 0 plus 1. Great. Well, the 0 plus 1s cancel out. I don't care about those. So my partially simplified form is this. -5 equals a times 25 divided by -15. So I multiply both sides, and I get 75 equals 25a, which means a equals 3. So here's our equation. F of x equals 3, that's the a value. X plus 5 squared, that's the bouncing x-intercept. X plus 1 on top and bottom, that's the whole. X plus 3, that's the odd vertical asymptote on the left. And x minus 5, that's the odd vertical asymptote on the right. That is your equation. And I want to point out a shortcut to anyone who's really been paying attention here. See that 3 right there? See that horizontal asymptote right here? When the horizontal asymptote is not 0, it's actually a really nice shortcut. We didn't need to do all this stuff. That was just, it always works. But when you see a non-zero horizontal asymptote, you can just stick it right in the equation.